Alright, here's our video for Unit 3, Day 5. We're still looking at parallel lines proofs, but we will be not using algebra, without algebra. So we're not going to do any of those properties of equality for these. We're going to look at just the angle relationships as congruent or supplementary. So remember, we've been talking about these theorems, okay? Corresponding angles postulate, alternate interior angles theorem, alternate exterior angles theorem, consecutive interior angles theorem. So basically it just says if parallel lines are cut by a transversal, then corresponding angles are congruent, alternate interior angles are congruent, alternate exterior angles are congruent, and consecutive interior angles are supplementary. Remember that that one is supplementary, not congruent. I also want you to remember these two theorems. The linear pair theorem, if angles form a linear pair, then the angles are supplementary, and the vertical angles theorem. If angles are vertical angles, then they are congruent. Okay? So write those down in your notes if you don't have them written down yet. Pause the videos so you have enough time to do that. And then we just have a couple examples to do. This video won't take us a long time. Alright? If you need more time to copy these down, pause the video. Again, make sure you're listening. Okay? And so I'm going to tell you something, and if you're listening to the video, you could potentially get some bonus points. Alright? So if you're listening, draw a smiley face anywhere on this page of notes, and you can get bonus points in class. Alright, now we're moving on. Okay, so here's our example. We are given this diagram. We are given that L and M are parallel, and we want to prove that angles 1 and 3 are supplementary. Now, 1 and 3 are none of these angle pairs we've listed above. Okay, 1 is an exterior angle, 3 is an interior angle, but they're on opposite sides of the transversal, so there is no direct relationship between those. But we do know a couple things. That's why I've marked angle 2. We know 1 and 2 would be corresponding angles, so they're congruent. And we know that 2 and 3 form a linear pair, so they're supplementary. So I'm going to use some of those ideas to help say that 1 and 3 are supplementary in my proof. Okay? So I'm going to use that shorter way of writing proofs. Okay, I'm going to start with step 1. I'm just going to list the given statement. L is parallel to M, and then instead of writing it as a column with a table, in parentheses I'll just put the reasons. And you're welcome to use this on homework assignments or on a test. If I don't give you the table, you can use this shorter way of writing the proof. So the next statement is what's going to come next. Well, the first thing I pointed out was the relationship between 1 and 2, because that comes directly from the parallel lines. So 1 and 2 are corresponding angles, so angle 1 must be congruent to angle 2 by the corresponding angles postulate, or theorem. If you're used to writing theorem there, you can write theorem. Okay? Now, in order to work through this, I'm going to use some substitution eventually to replace angle 2 with angle 1 in an equation, but that means I have to change these to equal angle measures. So I'm going to say measure of angle 1 is equal to measure of angle 2, just by definition of congruence. Alright? Because that's going to come into play in just a minute. Now, I need to also relate 2 and 3, because that's going to help me get from talking about angle 1 to connecting it to angle 3 for the proof. Okay, the relationship between 2 and 3 is that they form a linear pair, and so they are supplementary. I don't have to state that they're a linear pair. The diagram verifies that. So my next statement is what I know because they are a linear pair. Because they are a linear pair, I know they're supplementary angles. So I can say angle 2 and angle 3 are supplementary. Okay, that's by the linear pair theorem. Now, if they're supplementary, again, remember I was just talking about the measures of their angles, so because they're supplementary, I want to write out that equation, measure of angle 2 plus measure of angle 3 equals 180 degrees by the definition of supplementary. Alright? Now, look at what we've said. In statement 3, 1 is equal to 2, and I've said 2 and 3 add up to 180. I eventually want to be talking about 1 and 3. So since 1 is the same as 2, I can replace 2 with 1. So I can say measure of angle 1 plus the measure of angle 3 equals 180 degrees by substitution. But if I didn't have an equal sign, if I was still talking about congruent, I couldn't make that substitution here. So that's why I changed this in statement 3. So now the measure of 1 plus the measure of 3 is equal to 180. Well, if 1 and 3 have measures adding up to 180, that makes them supplementary, because that's what the word supplementary means. That's the definition of supplementary. So I can say angle 1 and angle 3 are supplementary by the definition of supplementary. And that's what I was trying to prove. Angle 1 and 3 are supplementary. So I've finished my proof. Alright, we're going to do one more quick example. This one is an even shorter proof, but another example of how we can prove lines parallel, or prove things about parallel lines, with non-algebra, just with facts about the angle measures, no numbers. Alright? So in this example, I've got two sets of parallel lines. Given M and N are parallel, but A and B are also parallel. So because I have two sets of parallel lines, when I'm talking about parallel lines M and N, A is one transversal and B is another transversal. In the same way around for these two, all four lines could potentially be transversals. So we're going to have to think about things a little bit differently in this proof, but it's actually a much shorter proof, and I'll work it out with you now. The first statement, again, needs to be the givens, both of them together. And now, we want to say that 1 and 3 are the same measure, so I'm going to help you make that connection before we write anything out. Angle 1 and angle 2 are corresponding angles because of these parallel lines and transversal A. They're corresponding angles, so they have to be congruent. But then if I turn this around and I look at parallel lines A and B, with N being the transversal, angles 2 and 3 are alternate exterior angles, so they're congruent. Well, if 1 is congruent to 2 and 2 is congruent to 3, we can say 1 is congruent to 3 by the transitive property. So that's all we have to do. We're just going to write that out in our proof. So let's go back. We're going to talk about angles 1 and 2 first. I know that angle 1 has to be congruent to angle 2 because they are corresponding angles along these parallel lines with that transversal. So that's the corresponding angles postulate for that. Then I also know that angle 2 is congruent to angle 3 because they're alternate exterior angles with those parallel lines. So I can say angle 2 is congruent to angle 3. I don't need to change to equality for any of this because I'm not actually adding or subtracting anything. I'm not using an equation. I'm just saying that they're the same measures by stating congruence. Again, 2 and 3 are alternate exterior angles. That's the alternate exterior angles theorem that makes these congruent. And now, just to quickly finish this up, if 1 is congruent to 2 and 2 is congruent to 3, we can say angle 1 is congruent to angle 3. And that is the transitive property of congruence. Sorry, I forgot my letter N. Transitive property of congruence. Okay? And that is what we were trying to prove. So we finished that proof. Short little 4-step proof. Okay, that sums up our notes. We'll do a lot more examples in class because I understand some of these are probably going to be kind of tricky. And make sure you have these written down and bring them with you to class, and we will